So this is about the diagrammatic structure. And in your examination, normally this would be asked for 6 marks. I explain the types of cable and its classification. So what you need to do is write the answers in point wise, very crispy answers. Okay, we should be very brief, not in detail at all. First, define what is coaxial cable. Next, write what is the types of coaxial cables. Write the diagrams and simply explain what is the rigid cable, what are the internal terminals and external terminals. Normally, they'll tell you to they may ask for explanation of any two types of cables, not all the three. Okay, depending upon the marks, you need to justify how much you want to write. You should decide how much you want to write. Okay, unnecessary, don't waste writing your answers which doesn't fetch you more marks in the exam. Depending upon the marks what has been allocated for that question, appropriate to that you write your answers. So this is about the coaxial types of cable. Is there any doubt?
No, ma'am.
Okay. So next, coming for the second topic, that is connectors and adapters. So the types of connectors and adapters. First of all, you need to know what is a connector and what is an adapter. See, please remember your lab devices, what you are operating, which will be operating. So let us take an example of a signal generator or function generator, or else let me take an example of CRO itself first. So a CRO, always you know it has two channels, channel A and channel B. And when you want to observe any output on a CRO, what is that you do is, let me take an example that you are observing the output of a simple rectifier circuit. So during that time, you have your rectifier circuit connected on your springboard, and let me take an example that this is the point where the output has to be obtained. So, and in the circuit, as you all know, there would be one ground point on the springboard. And a CRO probe consists of two terminals. That is, one is the terminal which goes and gets connected to the CRO. When you take a CRO probe, one of the terminal will go and get connected to CRO. Okay, that terminal is what we call it as connector. Okay, the terminal which you connect, just you flip it up or else you rotate it, right? The terminal is what we call it as connector. But on the CRO, there is one more terminal where the diameter of the terminal is lesser than the diameter of the CRO probe connector which you are connected, and that is what we call it as adapter. Because when you connect a connector, there should be an adapter to allow the propagation of the signal. Okay, you would have observed if you don't connect the CRO probe properly to the CRO, then also there are chances that you will not be able to observe the output of your circuit. In same way, suppose if you are done wrong connections, that is the output, the cable, the CRO probe, whatever you connect, the output should be obtained. The output wherever you want to obtain there, the positive terminal of the CRO probe should be connected, and the negative terminal should always go for the ground terminal. Okay, but if you interchange that positive negative, also you will not get the output. Got it? So all those are what we call as connectors and adapters. I'll just explain you once again. The connectors and adapters are the types of devices which are used for interconnection between coaxial cables and microwave components, which is which can be achieved with the help of standard connectors. Okay, the connectors and adapters are the types of devices, passive devices, which helps to interconnect the devices between the coaxial cables. So a CRO probe, when you take an example of a CRO probe, you can see the CRO probe will have a circular type of thing, and this is the black cable which you see, And on the other end of the CRO probe, you will have two banana clips where one will be red and the other one will be black. The one which is red, you will normally connect it to the circuit where you want to obtain the output, and the terminal whichever is black, normally you will connect to the ground terminal. Okay, and this part whichever goes and gets connected to the CRO is what we call it as connector. So unless until I have a coaxial cable, I cannot link a connector. Okay. If you just remove the CRO probe and see, there will be internally soldered. Okay. There will be a soldering done internally so that this connector will get connected with the coaxial type of cable. That is the black wire which you see, the cable. And on the other side, if I take an example that you are observing the output on CRO, then on the CRO there is channel A and channel B, and there you see some circle adapter like this, then output where you connect. So this connector you will connect it to the CRO. Okay, so this becomes the connector and this becomes the adapter. Got it? For example, one more example is very simple example. If you want to put your laptop for charging, what you do is you will take the cable, you will take the charging cable, and that charging cable has two ends. One end will go to the power supply switch where you want to connect, and on the other side you will go for the terminal which gets connected to your laptop, right? So this is what we call it as connectors and adapters. The output terminal of the cable is the connector, and the laptop terminal where you insert that cable, that is called as an adapter. Always an adapter has to get connected with the connector. That's why the connector and adapter always goes together. Okay, so that's why here also in the topic we call it as connectors and adapters. Connectors are the devices which helps the coaxial cables to get connected between the devices. And there are five types of connectors and adapters. The five types of connectors and adapters are navy connector, which is called as N type of connector. Next one is bayonet navy connector. The third one is threaded navy connector. Fourth one is sub-miniature A connector. And the fifth one is amphenol precision connector. These are the five types of connectors. So this is a diagram. Actually, individual diagram we could not take, but this is the diagram which is there in your textbook also, that is Annapurna Das. That's why that same image has been captured and kept in the PPT, so that when you go to the text, it would be easy for you people to analyze. Yes, this was done in the class. Okay, that's the purpose why the entire five types of connectors and adapters which was given is taken as an image. So these are the diagram of the connectors. Here you can see this is the BNC type of connector. Let me change the color. BNC connector, and this is amphenol precision connector. This is the SMA connector, and this is the N type of connector. Okay. So let us now understand what are they, why they are called as with different names, and what are the various properties. Okay. So coming for the first type of connector, which is the N type of connector or is a navy connector. This is what we call it as N type of connector. Type N connector, which is called as navy connector. The name for this connector was given as navy because in the initial manufacturing stages, on the initial use, it was used only for in the navy applications. That's why this connector is called as N type of connector. Okay, and this N type of connector will have male and female terminal. So This is a male terminal and this is the female terminal. Like it is somewhat similar to your CRO connection which you see, CRO probe connection. Okay. So this is the N type of connector. The N type of connector will have the male terminal, the female terminal. Well, the male terminal will go and gets connected to the adapter, whereas the female terminal will be given for the output of the device. Okay, and the navy connector will have a resistance of 50 ohms, or else it will have 75 ohms. And always the navy connector can be well connected with flexible type of cable, or else also rigid type of cables, which operates under the frequency range of 1 to 18 gigahertz. Okay, that's why when we are conducting the lab in microwave frequency range also, we make use of the same connectors which we have in the lab. We don't purchase a special type of connectors or as the cables, CRO cables. So a N type of connector is a navy type of connector, is called as a navy connector, which has male and female junction, and its characteristic impedance is either 50 ohms or 75 ohms, and it can operate in the frequency of 1 to 18 gigahertz, and it can be adaptable with flexible cable or is rigid type of cable. Okay, and coming for the second type of connector, that is BNC connector, Bayonet Navy connector. It is called as Bayonet Navy connector because later whatever the connectors that was used only for Navy applications, it was extended for other applications also. Like Navy, it was also used in submarines. It was used for lab purpose and all. That's why it was once again called as Bayonet Navy connector. That is BNC connector. And that is the type of connector which you are using in your labs also, communication lab. The CRO Pro, what you connect cable, whichever the connector you have is here BNC type of connector. Here you can see the diagram. This is the BNC connector, where this is what we call it as a connector. It goes and gets connected either with the CRO if you want to connect it to CRO, or else you connect it to the say signal generator also. If you want the input to be given, you connect it to signal generator or function generator. And the other terminal, this is what we call it as the output terminal. So even a Bayonet Navy connector, that is a BNC type of connector, as the male and the female terminal. The male terminal always goes to the output and the female terminal always proceeds towards the input. Okay, and once again the Bayonet Navy connector is suitable for the flexible type of cable or as a rigid type of cable, and this connectors can work up to the operating frequency of 12 gigahertz. Okay, and there is a characteristic impedance is either 50 ohms or 75 ohms for a Bayonet Navy connector. Coming for the third type of connector, which is the TNC connector or as the threaded navy connector. So what is threaded navy connector? Here in the diagram, let me first show that. Actually, here in the diagram, it has not given the threaded navy connector, but I'll just explain about this. A threaded navy connector is the one where when it has to get connected with the device, it will have thread type of structures where you need to rotate the connector so that it gets completely fixed. Okay, so that is what we called as a threaded navy connector. Means the N type of connector and the BNC type of connector, it will have a terminal where just you need to rotate and lock it. But a threaded navy connector is the type of connector where we need to just turn on the connector so that it gets completely connected with the device. Okay, like the main difference is whenever you want to just fix a nail on the wall, a direct nail, you hit hard on the nail and the nail gets into the wall. But in same way, there are also a few of the nails which is in the form of screw. A screw, as you have seen, it will have the circular type of rotation, and at the end it will have a flat surface. And what you do is you will just make use of a screwdriver, you will keep on rotating and rotating, and that screw will drill into the wall or is will drill into the wall, and it gets fixed as a screw. Okay, so I think you people know about a screw. In same way, the threaded navy connector is also in the form of a screw type of connector only, where you need to do the rotations. Once you do the turnings, then only the threaded navy connector gets connected. And this type of connector you will be using in your microstrip experiments in your communication systems lab. Okay, so the threaded navy type of connector is the one which has to be turned on to make the complete establishment of the link. If not, there are chances of signal propagating outside. There will be a loss of signal. That's why when you are conducting experiments in communication lab, that is with relevant to microwave devices, if you just leave some air gap in between the connectivity, then there will be huge loss of signal which you'll find in the output. Okay, so when you connect the cables in a microwave test bench experiment or else in microstrip technology experiments, then you should tighten the screws completely. If not, there will be a leakage of signal. Okay, so they are what we call it as threaded navy connectors. And the threaded navy connectors also will have a female junction and a male junction. The male goes to the output and the female comes to the input. Okay, female junction. Coming for the fourth type of connector, that is SMA connector, sub miniature A connector. So what is sub miniature? The sub miniature A connectors are the one here you can see SMA connector. Okay, I'll just take the green one. Sub miniature A connector. This is sub miniature A connector where you can see this the diameter of this layer is different, the diameter of this layer is different. Okay, and here it has a thread. Okay, so the diameter of representation, also the diameter where the connectivity has to be established, this as sub miniatures, means the diameter of this is different and the diameter of this connector is different. If you want, you can disconnect this and connect it. Okay, and these types of connectors are called as sub miniature A connectors. It is SMA connector. Similarly, we have SMC connectors also. Sub miniature A means it will have a different diameter. Sub miniature C means it will have a different types of it will have a different diameter. Means sub miniature A connector will be around 3.5 mm and sub miniature C will have around 7 mm. Okay, like that it varies. So SM stands for sub miniature. Depending upon the application, we can change this connectivity. Okay, and in SMA connector also we have male and female connectivity. We have the male terminal and then we have the female terminal in SMA connector. And the other type of SMA connector is SMC. It works as a different frequency. Hence, SMA connector operates at 24 gigahertz, whereas SMC operates at around 28 gigahertz. Okay. Coming for the last type of connector, which is the Amphenol precision connector, that is APC connector. APC is APC stands for Amphenol precision. So the type of material what we are using internally is called as amphenol, and the terminal is precised. Means the internally there will be some precise connections which is done. That's why it is called as amphenol precision connector. A amphenol precision connector is a special type of connector which is a sexless connector. It does not have a male junction and a female junction, a female terminal and a male terminal. It has only one terminal. So this is the example of a APC connector. This is the APC connector, and the APC connector is of two categories. One is 3.5 mm and the other one is 7 mm. Okay. So this is the amphenol precision connector, and this is the amphenol, and the precision is internally done, and the precision is also available at the connectivity point. That's why these are called as sexless connectors, because they don't have the male terminal and the female terminals. Okay. So this is all about the types of connectors. And this APC connectors can operate in the frequency range of 34 gigahertz. Okay. So this is all about the connectors and adapters. Let me guys about this connectors and adapters. We have 5 types of connectors, that is N type, the BNC, the threaded navy connector, the subminiature A connector, and the amphenol precision connector. The first 4 connectors are as the terminals have male and female, and the APC is the only connector which does not have the male or the female junction, so they are called as sexless connectors. And N type of connector can work from the frequency range of 1 to 18 gigahertz. Then BNC also can work from 1 to 18 gigahertz, whereas threaded navy connector can operate up to 24 gigahertz, and APC connector can operate up to 34 gigahertz. Okay. So in your lab, you can look at BNC connector and the TNC connector. Okay. So practically you have seen these devices.